Okay, in this podcast we're going to work through worksheet 10 where we are working on predicting products. This will be just like the test. Alright, so for each of these I've got to write the balance equations, identify the type of reaction, and balance it. So here I've got potassium chloride, which is KCl, plus sodium nitrate. Alright, so I've got two compounds, so what I'm going to do is replace both ions. So this is going to be a double replacement reaction. Right? So I think the easiest thing to do is just swap these two guys. So my sodium ends up with my chlorine. When I do that, sodium's a +1, chlorine's a -1, so that's balanced. Plus I'm going to end up with the potassium's going to end up with the nitrate. And again, this is a +1, this is a -1. Those would be my products. Now if I look on my ion sheet, what I see is sodium chloride, not my ion sheet, my solubility chart. I've got to decide whether or not this reaction occurs. Sodium is an alkali metal, so this is going to be soluble. Potassium is an alkali metal. This is going to be soluble, so this is a no reaction. Okay. Alright, let's look at the next one. Ammonium hydrogen carbonate. So it's kind of a mouthful. Ammonium hydrogen carbonate is NH4. Ammonium is that. Hydrogen carbonate is bicarbonate, is HCO3. That's a +1, -1, so that's balance. Plus sodium chloride. Whoops, forgot the sodium. Again, it's going to be a double replacement, so I'm going to end up with the ammonium and sodium switching places. So I'm going to end up with sodium hydrogen carbonate and ammonium chloride. So let's take a look at our products and decide whether or not we've got a reaction going. So sodium is the alkali metal, so this is always going to be aqueous. Now let's look at the chlorides. Ammonium's not listed, but the chlorides are, and what it says is chlorides are soluble unless with silver, lead, or mercury. So this is going to be aqueous also, another no reaction. And again, this is the double replacement. I've got two ions. Alright, here I have iron plus sulfuric acid. Sulfuric acid is going to be made from the sulfate ion. That's a -2, so I need two of those. Okay, so what I want to see is, will iron, this is going to be a single replacement, right, because I have an element in an ionic compound. So a single replacement. And so the only thing that can happen is iron replaces something. So the iron is, let me see, it's higher on the table, on the electromotive series table, the green sheet, than the hydrogen is. So it will, in fact, occur. Now the question is which iron to use. Now what you need to do is look at that electromotive series, because what is listed there for you is the most common ion that will form, and you should assume that that's the one that's going to form. So this is Fe +2, that's what the sheet says. SO4 is a -2, and then it's going to end up with hydrogen left over. And if I look, this equation is all balanced, so I'm going to voila it. I forgot my voilas. Okay. Alright, let's do the next one. Here we have an element in a compound. So again, this is going to be a single replacement. So I have aluminum plus sulfuric acid. And that is going to, the aluminum, if anything, will replace the hydrogen. And aluminum, in fact, is higher on the series than hydrogen, so it will occur. So I'm going to end up with the aluminum and the sulfate together. Now, aluminum is a +3, sulfate's a -2, so I need 3 sulfates and 2 aluminums. Remember, I always have to balance what I make over here. Plus the hydrogen is going to be kicked out, and that's diatomic, so I need a 2 there. So now I need to balance this guy, so I'm going to need 3 of these, and 2 of these, and I'm going to need 3 H2s. So that's a voila there. Okay. Sodium carbonate. Sodium carbonate. Carbonate's a -2, so I'm going to need 2 sodiums, plus silver chloride. Ag is a +1, Cl is a -1. Okay, when I do this, they're going to swap partners, so this is the double replacement. So I'm going to end up with sodium is with the chlorine, and the silver, I got to show the positive ion first, right, is with the carbonate. Now silver is a +1, carbonate's a -2, so I need 2 of those. So I'm going to need 2 of this and 2 of this. So let's just see if the reaction occurs. Sodium chloride is going to be soluble because it's sodium's an alkali metal. Now the carbonates are, let me see, carbonates are insoluble unless they're with an alkali metal, and it's not, so this is going to be my solid. Okay, so I do have a reaction, and everything looks like it's balanced, so that's going to be a voila. Alright, here I have 2 elements, lithium and chlorine. Lithium plus chlorine. Now I've got to always ask myself, are either of these diatomic? And in fact, that guy is. So I need to make that diatomic. The only thing that can happen is they can come together, right? This is a +1, -1, so that's balanced. So I'll need 2 of those and 2 of those. I can voila it. And this is going to be a synthesis reaction because I just have 2 elements combining together to make a compound. Alright, here I have sodium chloride plus potassium nitrite. Because it's a nitrite, I know I find it on the ion sheet. -1, +1. These guys, it's going to be double replacement, right? I've got 2 compounds. I'm going to end up with sodium nitrite. That's a +1 and a -1, and a potassium chloride. So when I do that, sodium nitrate, that's going to be aqueous. That's going to be aqueous. So this is a no reaction. Alright, I have a copper 1 bromide in lead. So this is I have a single element there, so that's going to be a single replacement. Copper 1 bromide is CuBr. Copper is +1 is what this tells me. Bromine's a -1 plus lead. Okay, now I'm going to look at that electromotive series and see whether or not the lead is more reactive than the copper. So lead is higher on the list than copper, and I'm going to assume I make the ion that's on the sheet, which is a +2. So I'm going to end up with a PbBr, and because this is a +2, I'm going to end up with 2 of those, so I'll need, and then the copper will end up by itself. So I'm going to end up with, I need 2 of those and 2 of those. Voila. Okay. I'm going to stop there for a minute.